When you hear flies, what do you think of? When you see a fly, you would probably want to get rid of it. But here, we do the opposite. Welcome to Cuprina, where flies are not a fiend, but a friend. Cuprina breeds a species of blowflies called Lucilla Cuprina for wound debridement therapy. Now, they're expanding their business to waste valorization by decomposing frog waste using maggots. But first, they need a biodigester, and that's where we come in.
Cuprina needed us to design a biodigester that could host the full life cycle of the flies. Our aim is to ensure the flies continue to lay eggs so that the larvae can be further used for wound cleaning and waste valorization purposes. But there was an important caveat. The flies typically lay eggs on rotting meat, but this is unacceptable under FDA requirements for eggs used for medical purposes. So, we have to find a way to guide the flies to lay eggs on a clean surface. We also need to take into account the preferred living environments at various stages of the life cycle. Therefore, we concluded that our group's problem statement is to design a biodigester with a focus on regeneration of the Lucilla Cuprina relation.
With all these requirements in mind, we went through rounds of brainstorming and evaluation. First, coming up with a biodigester directly attached to an egg laying cage, then a top-down compartment system with a rotating egg laying platform, followed by a side-by-side pupating and feeding area, and a collapsible egg laying cage for easier maintenance. Finally, we settled on a design that was approved by Cuprina. We also installed Arduino sensors that were programmed using C++ that measures temperature, humidity, and gas concentration to monitor the fly's environment.
We modeled our final design in 3D using AutoCAD. Our design consists of two parts, a biodigester and an egg-laying cage. The models are also visualized using Autodesk Maya and presented in Adobe Premiere Pro. We created an artificial egg-laying platform that will be placed above the rotting sheep's heart. This platform allows the rotting meat smell to permeate through and has built-in crevices for female flies to lay eggs on a clean surface. This meets FDA requirements and addresses our problem statement on population regeneration. Beyond addressing our problem statement, we also tackled an additional issue of the lack of ventilation in the biodigester. We included a mesh window for better airflow, with flaps that block sunlight for a dark environment needed for the larvae and pupae.
We tested our key prototype component, the egg laying platform, extensively. The egg laying platforms were placed in cages with mature female flies to determine its effectiveness in facilitating egg laying. We went through a few iterations and made improvements to our design along the way. We experimented with many versions which were made to simulate the texture and crevices in real meat and offer some convenience for egg collection. They are wavy surface with holes, sandwich-like structure with gaps, increased gap size, reduced gap size without wall, detachable top and base, and detachable plus gap reduced. Through experimental comparison, we adopted the reduced gap without wall as our final model due to its outstanding performance in population regeneration.
We also assembled our full prototype and successfully implemented it by placing some eggs on sheep suds in the feeding area of the biodigester. The feed will transition to frog waste after feed optimization. As we come to the end of our project, we are glad to say that we have learned a lot through the process. We would like to thank our supervisors, Dr. Joel Law, Chi Yuan and Felicia, as well as our technical team. Thank you for watching.